welcome to our next unit here called the representative particles. So the idea is we covered the mole in our last unit, and a mole can be used to measure a lot of different things. So for instance, you could say you have 1 mole of dollars, and that would be an absurd amount of money. Your eyes would probably be doing that. That is a lot of money. It's a really big number, 1 mole. Generally, though, we use the mole in chemistry. And in chemistry, we use the mole to measure amounts of representative particles. Representative particles could be atoms, probably the most familiar to you. It's the one we've used so far. So an atom of calcium, an atom of sodium, an atom of iron, or an atom of lead. Some examples there. So an atom is the first representative particle. 6.02 times 10 to the 23rd atoms of any element is 1 mole of that element. So here's an example. We've got, this is what copper wire looks like. If you could get all the way down to the atomic level, it might look like these little spherical balls here. With that copper color, those are individual atoms. So 1 atom of copper is the representative particle of copper. If you happen to have 63.546 grams of copper, you would have 1 mole of copper atoms. You would have 6.02 times 10 to the 23rd atoms of copper. How do I know that mass? Well, it's on the periodic table. That's the molar mass on the periodic table. Our next representative unit is called the formula unit, which you're allowed to abbreviate for U. So for U. You don't have to always write out the whole formula units, just for U. And examples of formula units are sodium chloride, NaCl, BaF2, that's barium fluoride, or calcium carbonate, CaCO3. So a formula unit is the smallest portion of an ionic compound. We haven't talked much about covalent and ionic bonds yet. You'll be more familiar with them later, but the smallest portion, when you get down to the smallest it can be, is just 1 of those. So table salt, when you put some salt on your french fries, you see it's like a fine white crystal. Well, there's billions and trillions of billions of NaCl's all stuck together that make up that white compound. And if you could get just 1 NaCl, that would be the formula unit. So just one of them, just 1 Na and 1 Cl, you would have the formula unit for you of sodium chloride. Here's a bigger picture of what salt would look like. Again, you've got just millions and millions of these sodium and chloride ions all bonded together in this big gigantic crystal of salt. And just like it was for atoms, 6.02 times 10 to the 23rd formula units, or 4U's, equals 1 mole of whatever ionic compound you're working with. So again, there's our table salt, NaCl, and just 1 Na and 1 Cl is the formula unit. If I had 58.442468 grams of table salt, I would have 1 mole of NaCl's. Again, how do I know that? Well, I used the periodic table, and I added the molar mass of sodium with the molar mass of chloride. So, found the mass of sodium on the periodic table, found the mass of chloride, added them together, and voila, 58.442468. Finally, our third type of representative particle, the molecule. So molecules, like H2O, that's water, CO2, carbon dioxide, NH3, that's ammonia. A molecule is the smallest portion of a covalent compound. So formula units are for ionic compounds. Molecules are for covalent compounds. Make sure you watch the abbreviation, MOLC. We can't just use MOL. We've already got MOL as an abbreviation for a mole. So we have to add that C right there so people know we're talking about molecules, the formula unit, and not MOL, the mole, which is a count. So it's just like the other two, 6.02 times 10 to the 23rd molecules equals 1 mole of molecules. In your typical Dasani water bottle, you have roughly 33 moles of water molecules. That's a lot. That's this many. I don't even know where to begin. There'd be a million, billion, trillion, gazillion, gajibavillion, just a gigantic number of water molecules. So again, to reiterate what a molecule is, it's two H's and one O. There's one water molecule. I think we're all familiar with water, H2O. There it is, just one of them. And the mass of one water molecule is 18.01528 grams. Again, where did I get that? Well, I added together 2 of the molar mass of hydrogen and 1 molar mass of oxygen. Watch the 2. It's H2O, 2 H's, 1 O. Added those together off the periodic table, and I got 18.01528 grams. Let's take a look at a couple examples. So given 6 grams of calcium nitrate, determine the number of moles. So question mark, moles of calcium nitrate equal to 6 grams of calcium nitrate. What are we looking for? What did they give us? We need to add together, off the periodic table, the mass of calcium, 2 times the mass of nitrogen, because there are 2 nitrogens, and then 6 times the mass of oxygen. 6 because there's 3 O's inside the parentheses, and we have 2 of everything in the parentheses. So that's 6 total oxygens that we have in this compound. So 6 times 15.9994. I add all those up. I pay attention to my adding rules. Can't go past the hundredths column. If we take a look at calcium, it only goes to the hundredths column. So my last significant digit's in the hundredths column, 164.209. 2 is an extra digit. I don't want to round it off just yet, so I underline it to show that it's not significant, but I'm keeping it for now. Again, that's my grams per mole. It's my molar mass of calcium nitrate. It's a formula unit. So with my grams, I can go to moles. I want to cancel out grams, so I know that my 164.2092 grams goes on the bottom. 1 mole goes on the top. If my grams cancel out, I'm left with moles, and there we go. What we need to do for this problem is divide 6.00 grams by 164.2092 grams of calcium. And by lining up my units, making sure I have the appropriate number with each unit, I have figured out how to solve this problem. Final answer then, with appropriate significant digits, I only had 3 in 6.00, so I should only have 3 in my final answer, 0.0366. The zeros are not significant, they're on the left, so only the 3, the 6, and the 6 are significant. One more example here. So given 8 grams of calcium nitrate, determine the number of formula units of calcium nitrate. So here's the nice thing about doing the math and solving for the mass of a compound, whether it be a molecule or a formula unit, is oftentimes you get to use that same mass over again. I don't have to do this math again. I've already done it. So same compound here. This time, though, we have 8 grams, and we're not just stopping at moles. This time we have to go all the way to formula units. How many total calcium and nitrates do we have? So question mark, 4U's calcium nitrate is equal to 8 grams of calcium nitrate. Here's what the question's asking for. Here's what the question gave us, 8 grams calcium nitrate. I know that I need grams on the bottom. I can go grams to moles. I can't go grams to formula units. I don't have that conversion, but I can go grams to moles. That's what this value here is. It's a molar mass. 164.2092 grams of calcium nitrate per mole. So I put that 164.2092. I'm not sure what happened to my 2092. Yikes, that's embarrassing. Put that on the bottom to make sure that my grams calcium nitrate cancels out. My moles of calcium nitrate. Now that I have moles, I know that moles has to go on the bottom, and I can go from moles to formula units. It's 6.02 times 10 to the 23rd of whatever I have. Formula units, atoms, molecules, dollars, if you're really rich. It's that many dollars, 6.02 times 10 to the 23rd dollars in 1 mole of dollars. So 1 mole of calcium nitrate has 6.02 times 10 to the 23rd formula units of calcium nitrate in it. So now I've got just some multiplication division left. 8.00 divided by 164.10. Again, not sure exactly what happened, why my number changed. We'll run with it for now. Times 6.02, big E, 23. I got 2.9348 times 10 to the 22nd, 4 U's calcium nitrate, formula units of calcium nitrate. Again, with appropriate significant digits, the 8.00 only has 3 significant digits, so I only have 3 in my answer. 2.93 times 10 to the 22nd, formula units of calcium nitrate.